Welcome to today's lesson. This is Math 101 and I'm Mr. Gressman, and this is lesson number 12. Welcome to today's lesson. As discussed in class, our project for the next few weeks will be of designing the bowling ramp for use by those with a handicap. You will go over the physics of this project in your science class to come up with the basic concept, then figure out the geometry of the design and record it on a coordinate grid system here in math class. This method of recording geometry of an object onto a coordinate system is how products are commonly designed today. This is done with computers using computer-aided design, or CAD for short. You've probably seen examples of CAD in commercials or movies where there's an outline of an object imposed on a grid on a computer screen like this picture. Car commercials sometimes use this when talking about the design going into a car, for example. Each of the lines that you see in the picture is stored in the computer with data on the endpoint location of each line and its length in a three-dimensional coordinate system. The basic concept behind CAD is that the lines, arcs, and curves are defined by equations, then located relative to each other by XYZ coordinates to form the shape of the object. In this video, you will learn about the basics of this manipulation of pieces of geometry to form objects for the design of our bowling ramp. You will be using graph paper to record instead of a computer, but the basic idea is the same. Instead of a grid on a piece of paper, the data is stored in the computer memory on an electronic grid. The grid planes in this picture show how the initial car design is mapped onto the grid system. If you imagine the grid planes in the picture as pieces of graph paper, you can get the general idea of how a CAD works and how our graphing geometry on a paper would relate to it. In the first task, you will review how to create lines, arcs, and then how to size and locate them in two dimensions like the grid planes in the picture to define the shape of the ramp. We've already covered this material, so it should be all familiar and go pretty quick. Remember, it's all about numbers, the equations for numbers defining the shapes of the pieces and the numbers of the coordinates locating the pieces. In the real world, the resulting design information will be given to the manufacturing department to actually make the ramp, often using numerically controlled machinery that reads the information directly off of the CAD design. It's all about the numbers of how points are located in the coordinate system. So watch this video to get a better idea of how coordinate systems are used in design and manufacturing. And you can also find the link for this website in Edmodo. The links are organized by slide number. This is slide number 5. So after you view that video, come back here and we'll continue. Okay, our first task, we are going to review graphing equations in two dimensions. The first step is to create a table of points from the equation. And you can see the example over here. And this is similar to the assignment that was handed out in class today. So the equations over here define the points, and then over here these give the limits of the shapes that are created, like how long a line is or how much of an arc would be, or how much of the geometry is actually plotted. The instructor refers to in the video to the limits as fences. The application for our project is how to write equations to define geometry, then plot it on a coordinate system, which we will do for the geometry of our ramp. So go watch the video and then do the 3 problems you were given in the handout in class today. And then return here and we'll continue on. Okay, next we will review translation of geometric objects. The exercise in this video covers moving geometry in 2 dimensions, but think about moving objects in 3 dimensions, and we will discuss that in class when we meet next. So we'll first review moving in 2 dimensions, and then in a 3rd dimension you add a z-axis. So again, we'll cover that in class, and then again a little bit later in the video as well. So the application for the project will be to define geometry of the ramp, then move pieces around to refine the design. Then once a shape is defined, a copy of the shape will be moved on the z-axis to give thickness to the shape using a 3-dimensional coordinate system like the one we looked at earlier in this lesson. So go to the link, and then there quiz that comes after the lesson, and take that and then come back here and we'll continue on. Okay, now that you're all back up to speed on geometry in a two-dimensional coordinate system, let's look at systems with a third dimension using the z-axis. Just imagine another axis coming up out of the paper for 3 dimensions. That's the real world. Okay, let me take you to a great math website and look at this a little more. It's called shmoop.com, and they've got a lot of great material to teach you about math. Okay, so here we have, this is the two-dimensional graph system that we've been working with so far. We have a y-axis and your x-axis. Okay, and then you just imagine the z-axis coming up out of the paper, like it's shown here. And then here's the axes as they would be defined relative to each other. You can see here's the x, y, and the z coming up out of the paper. Okay. Then the application for creating a three-dimensional object. Again, here you've got your y, your x, and your y. And let's say you create a triangle, and then you make a copy of that triangle and move it out along the z-axis and connect it with lines, and now you've got a three-dimensional object. So it's the same basic concept of creating objects and moving them around on a coordinate system, but instead of doing it on a flat piece of paper, now you're doing it in 3 dimensions and coming out to create a three-dimensional object. Okay, and here's another example. Here's an example of the rectangular prism. Here's the points of the prism in 3D space. So go ahead and take a look at this website, and so when you put this all together, you're creating shapes and pieces of shapes and moving them about in 3D space to design a useful object. So when we meet next in class, you'll use these concepts to create the 3D dimensional design of the bowling ramp. See you then.